One way you can solve a system of equations is by elimination. In this method, you have to line up your x's and your y's. Then you multiply one or both equations by a number so that you end up with a positive and negative version of a coefficient for one of your variables. So for instance, you might end up with a positive 6x and a negative 6x. You do this because when you add the two equations, that variable will cancel out. Positive 6 and negative 6 add to 0. Which means you'll only have one remaining variable that you can solve for. Once you have that variable, you plug in an answer to the original equation to get a second variable. So I'm going to use some of the same equations I used in one of the previous examples from the substitution video. So let's take, for example, 6x minus 5y equals negative 45, and 2x plus 2y equals negative 4. I showed you how to solve this equation, or system of equations, in the substitution video. But you can also solve this one by elimination. Now in this problem, there's more than one way you can do it. I can choose to eliminate the x's or eliminate the y's. In this problem, I'm going to choose to eliminate the x's because I know that if I multiply this bottom equation by a negative 3, I'll end up with negative 6x, and that will cancel it out. So I'm going to rewrite my equation over here. Negative 6x minus 5y equals negative 45. And now I'm going to multiply each of these terms by negative 3. So I get negative 6x minus 6y equals positive 12. And now when I add my equations together, 6x minus 6x gives me 0. It cancels, which leaves me with negative 11y equals negative 33, which means y is 3. And then I can take it and plug it into one of the originals to get the other. So 2x plus 2 times 3 equals negative 4. Gives me 2x plus 6 equals negative 4. Subtract 6 to get 2x equals negative 10, and divide to get negative 5. So there's more than one way you can solve a system of equations. It just honestly depends on what you think is easier. So another example. Let's take okay, let's try this one. 9x plus 4y equals negative 72, and 2x minus 3y equals negative 16. Well, in this one, there's no easy way to do it unless you want to go into decimals. Or you can multiply both equations by a number to make it cancel. So, for instance, if I wanted to cancel out my y's, I can multiply the top equation by 3 and the bottom equation by 4. Because if I do that, I'll get 12y and negative 12y, which cancels out. So multiply everything in the equation by 3, and I get 27x plus 12y equals negative 216. And on the bottom, I'll get 8x minus 12y equals negative 64. And then I can add the two equations together. My y's cancel out, they add to 0, which leaves me with 35x equals negative 280. When I divide by 35, I get negative 8 for my x value. Then you take it and plug it into one of your two original equations. So if I choose the bottom one, because it's got smaller numbers, I'll plug in a negative 8 for x, and then I can solve for y. So when I do this, I'll get negative 16 minus 3y equals negative 16. I add 16 to both sides, which gives me negative 3y equals 0, which means y is 0. So the answer to this system is negative 8, 0. Now you do have to be careful though, when you do elimination, you have to make sure that your x's and y's line up. So let me take another one I did in the substitution video. 14x plus 7y equals negative 7. And y equals negative 2x minus 1. Right now, my x's and y's don't line up. In this one I have x and y on the same side, but on this one they're not. So what I'm going to do is I'm going to add 2x to both sides. So I can rewrite this as 14x plus 7y equals negative 7, and 2x plus y equals negative 1. So what I'm going to do, I'm going to choose to eliminate the y's, because anytime I have a coefficient of 1, that's a pretty easy one to manipulate. So I can multiply this by negative 7 to cancel out the top one. So if I multiply this one by negative 7, I'm going to rewrite my equations down here. 14x plus 7y equals negative 7, not changing that one. But when I distribute a negative 7 on the bottom one, I get negative 14x minus 7y equals positive 7. And this one's a special case because the 14s cancel, the 7s cancel, I'm left with 0 on the left side. On the other side, I'll also have 0. So this one is infinitely many solutions. So anytime you're working an elimination problem, just remember that you have to have a positive and negative version of the same coefficient for one of your variables. One has to be positive, one has to be negative, because when they add, you get 0. And remember, you can always plug your numbers, your answers back into the original equation to check yourself. So one more and I'll show you how to do that. Let's take an easy one. 3x plus y equals 11. And 5x minus y equals 21. This one, it's set up to where the y's already cancel. We don't have to do anything special. So I get 8x equals 32, which means x is 4. If I plug into one of the originals, I get 3 times 4 plus y equals 11, which means 12 plus y equals 11. And y, when I subtract 12, means I have negative 1. So 4, negative 1 is my answer. The way you check yourself is you plug in the numbers to both of your equations. So I'm going to do it down here. If I do 3 times 4, my x value, plus negative 1, well, 12 minus 1 gives me 11. That's what it's supposed to equal. That one checks out. But it has to work in both equations. So if I had 5 times 4 minus negative 1 equals 21. Well, this is 20. Minus and negative is adding, so 20 plus 1 gives me 21. That checks out too. Remember, when you go to check yourself, you have to plug it in both equations for it to be a valid answer.